This presentation is for course EE586, homework number 3, problem number 14 by Jim Cochran. For this problem, assume that hosts A and B are directly connected by a 100 megabit per second link. There is one TCP connection between the two hosts, and host A is sending to host B an enormous file over this connection. Host A can send its application data into its TCP socket at a rate as high as 120 megabits per second, but host B can read out of its TCP receive buffer at a maximum rate of only 50 megabits per second. Considering the effect of TCP flow control, what is the effective sending rate of A to B initially? Since the link's capacity is only 100 megabits per second, host A's sending rate can be at most 100 megabits per second. Considering the effect of TCP flow control, what is the approximate rate at which the receive buffer fills up? Since host A transmits at 100 megabits per second, but host B can only receive at 50 megabits per second, the receiver buffer fills at a rate of around 50 megabits per second. Considering the effect of TCP flow control, what happens when the receiver buffer is full? When the receive buffer is full, host B signals to host A to stop sending data by setting the receive window field to 0. Host A then stops sending until it receives a TCP segment with the receive window value greater than 0. Considering the effect of TCP flow control, what is the overall effect of TPC flow control on the sender, that is, host A? Host A will repeatedly stop and start sending as a function of the receive window values that it receives from host B. On average, the long-term rate at which host A sends data to host B as part of this connection will be no more than 50 megabits per second.